Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. It's 2:14 in the morning and the hospital's billing system just went dark. The only person on call has never logged into a Linux server. That person is about to be you. This is part 6 of Zero to First IT Job. Last time you got comfortable with Windows Server. Now we're going after Linux, the operating system running most of the servers behind everything you use. By the end of this video, you will be able to do 3 job-relevant things. First, explain what Linux is and why it appears throughout servers, cloud systems, containers, and network appliances. Second, move around the Linux file system and manage files from a terminal without guessing where you are. Third, read permissions, change ownership safely, and install software using the package manager that belongs to the Linux family you are supporting. These are not memorize every command skills. They are the habits that help you stay oriented, avoid breaking access, and troubleshoot methodically in an entry-level IT role. Linux is the kernel, the core software that manages hardware, memory, processes, and access to the machine. A Linux distribution is the complete operating system you actually install and use. It combines the Linux kernel with system tools, a shell, libraries, a package manager, configuration defaults, and software repositories. So Ubuntu, Fedora, Debian, and Red Hat Enterprise Linux are distributions. They share the Linux kernel at the center, but they make different choices around software management, release schedules, and defaults. In everyday conversation, saying, "I installed Linux," is fine. In an interview, be more precise. You installed a Linux distribution. Linux is not one narrow specialty. You will encounter it in help desk escalation, system administration, cloud operations, cybersecurity, networking, DevOps, and software development. The job title changes, but the foundation is similar. You need to connect to a system, understand where its files and logs live, check its services, and install or update software safely. The important takeaway is not that every IT job requires the same depth of Linux. It is that entry-level Linux fluency makes you more useful in almost every infrastructure-focused role. Learn the fundamentals now, and you will have a base you can deepen later. Linux distributions usually belong to a family, and the family tells you a lot about how software is managed. Debian and Ubuntu commonly use the apt package manager. Fedora, Red Hat, Enterprise Linux, Rocky Linux, and Alma Linux commonly use DNF. The goal is the same on both sides. Find trusted software, install it with its dependencies, update it, and remove it cleanly. The command names and repository tools are different. Before you copy a command from a tutorial, identify the distribution with cat, etc. OS release. Then use the package manager that belongs to that system. Ubuntu is common in beginner labs and cloud images. Red Hat family systems are common in enterprise environments. Learning both command patterns gives you a more useful starting point than memorizing only one. Quick check before we move on. What is the difference between Linux and a Linux distribution? Most Linux servers do not have a monitor, keyboard, or graphical desktop attached. You manage them across the network with Secure Shell or SSH. The basic pattern is SSH, followed by your username, an @ symbol, and the server name or IP address, // username a server address. The first time you connect to a server, SSH may show you that server's host key fingerprint. Do not accept it blindly. Compare it with a trusted source such as your organization's documentation or an administrator before you continue. That check helps confirm that you are connecting to the server you intended to reach. A local login happens at the physical console. An SSH login happens over the network. Either way, once you sign in, you are working inside a shell on that Linux system. Here is the command pattern for opening a remote Linux session. SSH username a server address, replace username with the account assigned to you, and replace server address with the hostname or IP address you were given. On a first connection, verify the host key fingerprint before you type a password. Then enter your password when prompted. You will not see characters appear as you type. That is normal security behavior. When the prompt changes to show the remote server's name, stop and confirm where you are. From this point forward, commands you type run on the remote machine, not on your laptop. That distinction prevents a lot of beginner mistakes. For routine administration, use SSH key authentication instead of repeatedly entering a password. You create a key pair, a private key that stays protected on your own computer, and a public key that you authorize on the server. The server uses that public key to verify that you control the matching private key. Start by creating a modern key pair with SSH Keygen, TED25519. Protect the private key with a strong passphrase. Then use your organization's approved method to add the public key to the server account. On many Linux and Mac OS systems, SSH copy ID username a server address can help, but always follow your team's access process. The goal is not to remove security. The goal is to replace reusable passwords with a stronger, easier to audit sign-in method. Never copy, email, or share your private key. Two terms people often mix up: shell and terminal. The terminal is just the window or screen where you type. The shell is the program running inside that window that reads your commands, interprets them, and carries them out. Many Linux systems include a shell called bash, and other shells are available. When a training course says you'll work from the command line, that usually means you're using a terminal to interact with a shell. A common mistake is calling the terminal itself the shell. The terminal is just the frame. The shell does the actual work. Quick recall. What command opens a remote Linux session? The pattern is SSH username a server address. Before you sign in for the first time, verify the server's host key through a trusted channel. Remember, SSH is not just a way to type remotely. It is the secure front door to the systems you support. 3 commands will keep you oriented in almost every Linux shell: pubdb, ls, and cd. But it prints your current directory. ls shows what is inside a directory. Run else lay when you want more detail, including hidden files, ownership, permissions, sizes, and timestamps. To move into a directory, use cd directory name. To move up one level, cd. To return to your home directory, cd. Once you know where you are, you can begin managing files and directories. Create a directory with mkdirpractice. Copy a file with cpnotes.ext notes. Backup .ext. Move a file with mvnotes.txt practice. The same command can rename a file. mv old name. Text. To remove a file, arm file name. Be careful with arm. command line deletion may not provide an easy recovery option. You may eventually encounter armr, which removes a directory and its contents recursively, or armarf, which adds force to that operation. Never copy these commands blindly from a tutorial. With elevated privileges or the wrong path, a mistake can remove large amounts of data. Before an important file operation, build a simple habit. Run pbudl. Inspect the target with ls. Read the command again, then press enter. Navigate, verify, then act. That habit can prevent an expensive mistake on a production server. Let's create a safe practice file in your home directory. First, confirm where you are with pwd, then run touchnotes, text, to create an empty file. Open it with nanonotes, den. Type one line, such as Linux practice file. In nano, press Ctrl-O to write the file, press enter to confirm the name, and press Ctrl-X to exit. Now run catnotes.txt to print the file back to the terminal and confirm that it's saved. Nano is a good first editor because it shows its keyboard shortcuts at the bottom of the screen. Later, you can learn Vim or another editor, but do not confuse tool popularity with a requirement to use it on day one. Most beginner tutorials ignore the graphical desktop, but help desk tickets often involve it. In a typical Linux file manager, you can create folders and text files through the same kind of right-click menus you'd expect on any desktop. You can also open a file's properties to see the access rules the system applies. The same permissions the terminal enforces, just shown in a graphical view. Before you edit an unfamiliar file, check what it is. Run file followed by the file name. For example, file notes, txt. For a plain text file, you may see a result such as ASCII text or UTF-8 Unicode text. For a compiled program, you may see ELF executable. That tells you something important. A configuration file is usually safe to inspect in a text editor, but opening a binary program in an editor will not make it readable or useful. Do not guess based only on a file extension. Use the file command first, especially when you are working on someone else's server. You see this permission string in a long listing, rwxrxra. The first character, the dash, means it is a regular file. The next three characters belong to the owner, read, write, and execute. The middle three belong to the group, read and execute, but not write. The final three belong to everyone else, read only. So the answer is, members of the files group can read and execute the file, but they cannot change its contents. Linux starts from one top-level directory, a /, called the root directory. From there, the system branches into directories with common purposes. Home usually contains regular users' home folders. Etc. contains system-wide configuration. var holds changing data, including many logs. TMP is for temporary files. USR contains much of the installed user space software. You may also see bin and sbin. On many modern systems, those locations are linked into USR. The exact contents vary by distribution and organization, but this shared layout gives you a map. Learn the purpose of the major directories before you try to memorize every path inside them. Let's use that map. First, run cd, etc., then run pbody to confirm that you are in the system configuration directory. Next, run ls var to see examples of changing data and logs. Finally, run cat xos release to identify the distribution and version you are supporting. That last command is especially useful before package work. It tells you whether you are on a Debian family or Red Hat family system, which helps you choose the correct package manager commands. When you are exploring a production system, use read-only commands first. Listing a directory and viewing a text file are safer than changing files before you understand their purpose. An absolute path starts at the root directory and gives the complete route to a file, such as /config. A relative path starts from where you are now, such as logs.app.log. Use absolute paths when precision matters, especially in documentation, tickets, scripts, and commands you will run with elevated privileges. Use relative paths when you are already working inside a known directory. The parent directory shortcut is each moves up one level, so cd moves up 2 levels. After any navigation that matters, run PUI. Do not trust your memory when the command can tell you the answer. So far, we've talked about controlling who can access a Linux system. Now let's talk about what happens when an authorized user needs administrative power. Linux has a special administrative account called root. Root can perform actions normal users cannot. Install software, modify protected system files, change ownership, manage services, and alter system-wide configuration. That power is exactly why administrators should not casually perform everyday work as root. Instead, many Linux environments use sudo. For example, sudo apt update. The command after sudo runs with elevated privileges, assuming your account is authorized to perform it. You can check which sudo operations your account is allowed to perform with. Sudo. L organizations may restrict administrators to particular commands rather than granting unrestricted administrative access. This follows a principle you've already seen. Least privilege. Use your normal account for normal work. Elevate privileges only when the task requires them. And whenever you see a command beginning with sudo, slow down long enough to read the entire command before pressing enter. A mistake as a normal user may fail with permission denied. The same mistake with administrative privileges may succeed. That's why administrative access should be intentional, limited, and carefully used. Linux systems can produce enormous amounts of text. Logs, configuration files, command output, process lists, and diagnostic information can contain hundreds or thousands of lines. You usually don't want to read all of them. That is where grep becomes extremely useful. Grep searches text for a pattern. For example, grep error application. Log. This searches the file for lines containing the word error. Linux searches are normally case-sensitive, so error and error are different. Add I when you want the search to ignore capitalization. Grep I error application. Log. You can also search recursively through directories. Grep R listen or etc. nginx. Now combine grep with another Linux concept, the pipe. The pipe symbol takes the output from one command and sends it into another. For example, psef uppers grep nginx. First, epsf produces the process list. Then the pipe sends that output to grep. Finally, grep shows only lines containing nginx. Think of a pipe as saying, take this output and give it to the next command. This combination, commands, pipes, and text filtering, is one of the foundations of working efficiently from a Linux terminal. When something fails on Linux, don't immediately start changing settings. Look for evidence. Linux systems record information about services, authentication attempts, errors, warnings, and system events in logs. On systems using systemd, one of the most important tools is journalctl. That can produce a lot of information, so normally you narrow the search. To inspect messages for a particular service, use journalcl u service name. For example, journalcl u nginx. On a Red Hat family system, you might investigate SSH with journal-cli ussd. Another command you may encounter is journal-cli x. The E option jumps toward the end of the journal so you can inspect recent events. The X option adds explanatory information from the message catalog when that information is available. Think of it as a way to quickly examine recent journal activity with additional context, not as a view limited only to high-priority errors. Traditional log files are also commonly stored under var log. Depending on the distribution and service, you may encounter files such as var log syslog, var log messages, or application-specific log directories. The tail command is especially useful when troubleshooting a log that is actively changing. For example, tail f var log syslog. The F means follow. New log entries appear on your screen as they are written. Press Ctrl-C when you're finished. Don't try to memorize every possible log location. Build the troubleshooting habit. Check the service. Read the logs. Find the error. Understand what it means. Then decide what to change. Logs turn guessing into evidence. A former employee's password login is disabled, but the security review shows that their account can still access a shared team folder. What should you investigate next? Start with the account's group memberships and the folder's owner, group, and permissions. Then follow the offboarding checklist for other access paths, including SSH keys and elevated privileges. A disabled password does not automatically prove that all access is gone. Read, write, and execute permissions mean different things depending on whether you are looking at a file or a directory. For a regular file, read lets you view its contents. Write lets you change its contents. Execute lets the system run it as a program or script. But deleting a file is different. Deletion is controlled mainly by the permissions on the directory that contains the file, not by the file's own write bit. For a directory, read lets you list names inside it. Write lets you create, rename, or remove entries there. Execute means you can enter the directory and traverse through it. That distinction is why permissions can feel confusing at first, and why you should always ask, am I changing a file, or am I changing a directory? The chmod command changes permission bits. Start by checking the current mode with ls, L file name. Permissions can be written as numbers. Read is 4, write is 2, and execute is 1. Add those values for the owner, group, and everyone else. For example, chmod 644 notes.txt gives the owner read and write access, while group and others can read only. That is a common mode for a regular text file. For a script or directory that others need to enter or run, chmod 755 name gives the owner read, write, and execute access. Group and others get read and execute access. Do not use 755 by habit. Choose the most restrictive mode that still lets the task work. Permissions only tell part of the story. Linux checks who owns a file and which group owns it before it decides which permission set applies. Use chown user.group file name to set both the owner and the group. For example, sudo chown appuser.appteamapp.conf. Use grp group name file name when you only need to change the group. Changing ownership often requires elevated privileges, so pause before you run it. Confirm the correct account and group with ID username, make the change, and verify it with lsl file name. A fast verification step catches mistakes before they become an access outage. A world-writable directory allows every local user to create or change entries inside it. That is sometimes intentional. For example, OntTMP is designed for temporary files, but it is protected with an additional rule called the sticky bit, which limits who can delete those files. Outside of intentional shared locations, world-writable permissions are usually a warning sign. They can allow the wrong user to alter content, replace a file, or interfere with an application. Use least privilege. Give an account only the access it needs. Read when it must view, write when it must change, and execute when it must run or enter. Avoid broad access as a shortcut, and verify the result with ls/ld directory name for directories, or ls/l file name for files. Let's lock in what you just learned. You're setting up a personal folder that only you should be able to read or edit. What principle should guide the permissions you assign? Say it out loud. Least privilege. Start with the most restrictive access that still lets the job get done, and only add read or write where it's actually needed. A package is a managed bundle of software plus metadata about what it provides and what it depends on. A repository is a catalog of packages your distribution knows how to retrieve, verify, and update. The safe default is to install software from your distribution's approved repositories. The package manager can resolve dependencies, record what it installed, and participate in future updates. A local package file can contain dependency information too, but it may come from an untrusted source, may not be maintained for your system, and may require dependencies that are not available or compatible. On Debian and Ubuntu, you will usually use apt. On Fedora and Red Hat family systems, you will usually use DNF. Before adding a third-party repository or installing a downloaded package, verify its source, ownership, signature process, compatibility, and support policy. It installed is not the same as it is safe to run in production. On Debian and Ubuntu, start by refreshing the local package index, sudo apt update, then install the package you need. For example, sudo apt install nginx. On Fedora and Red Hat family systems, use DNF. Sudo DNF install nginx DNF checks expired repository metadata as part of normal use. If you specifically need fresh metadata before an action, use sudo DNF. Refresh install nginx. In both families, read the transaction summary before you approve it. Notice which package you asked for, which dependencies will be added, and whether anything will be removed. Sudo means you are running the command with administrative privileges, so treat the confirmation screen as your last review point. The concepts transfer even when the commands differ. On Debian and Ubuntu, use apt. On Fedora and Red Hat family systems, use DNF. To refresh available package information, use sudo apt update on apt systems. On DNF systems, metadata is normally refreshed when it has expired. Sudo DNF make cache refreshes the cache explicitly. To install, use sudo apt install package name or sudo DNF install package name. To remove, use sudo apt remove package name or sudo DNF remove package name. To search, use apt search keyword or DNF search keyword. Do not memorize the logo. Identify the distribution first. If cat or sos zachar OS release says Ubuntu, use the apt pattern. If it says Fedora or Red Hat Enterprise Linux, use the DNF pattern. Do not guess a package name. Search the repository first. On Debian and Ubuntu, run apt search nginx. On Fedora and Red Hat family systems, run DNF search nginx. Once you find a likely match, inspect it before you install it. Use apt show package name or DNF info package name to review the description, version, repository, and other details. If the change is important, preview the transaction rather than rushing through the install prompt. The habit to build is this: search, inspect, install, verify. That sequence reduces surprises and gives you a useful trail to put in a ticket or change record. You are on an Ubuntu server and need to install a package. What is the safe beginner sequence? First, confirm the package name with apt search. Next, refresh the package index with sudo apt update. Then install the package with sudo apt install package name and read the transaction summary before you confirm. The command matters, but the workflow matters more. Identify, refresh, review, install, verify. To troubleshoot a network problem, separate 4 ideas. The IP address identifies your machine on a network. The prefix length or subnet mask defines which addresses are local. The default gateway is the next hop used to reach other networks. DNS turns names, such as example.com, into IP addresses. To inspect your addresses, run IP address. To see the default route, run IP route. To see DNS configuration on a system using systemd resolved, run resolve status. On other systems, resolve.conf may show the configured name servers, but remember that Network Manager or another service may manage that file. Troubleshoot in order. First, confirm the interface has an address. Then confirm there is a root. Then test reachability. Finally, test name resolution. That order turns "the network is broken" into a precise question you can answer. Start by checking your interface and address with IP address. Then check the default route with IP route. Next, test reachability to a known IP address, such as ping, a COR4 8.8.8.8. If you receive replies, you have demonstrated that this machine can reach that address using ICMP right now. It does not prove that every internet service is healthy, because some networks and hosts block or deprioritize ICMP. Then test a host name, such as ping, c4example.com. If the IP address test works but the host name test fails with a name resolution error, DNS is a strong suspect. Check resolve.ytl status or your system's resolver configuration next. When a remote destination is unreachable or slow, traceroute can show the network hops your traffic appears to take. On some systems, you may need to install the traceroute package first. Run traceroute destination name or traceroute destination IP. Each line represents a hop that responded. Asterisks do not automatically mean the network is broken. Routers can block or rate limit the probe traffic, and the return path can differ from the forward path. Look for a pattern where responses stop, whether later hops still answer, and whether the same behavior appears from another network. Use Ctrl-C to stop the command early. Treat traceroute as one clue, not a final verdict. Combine it with DNS checks, ping, service port tests, and the incident context. A process is a running instance of a program. A service is work that the system runs in the background, often under a service manager such as systemd. One service can involve more than one process, so do not treat the two words as perfectly interchangeable. When a server feels slow, collect evidence before you diagnose it. Check CPU activity and memory pressure with top or htop if it is installed. Check a memory summary with free h. Check disk capacity with df h. Then look for the specific process or service that is consuming resources or reporting errors. This is the difference between saying the server is slow and saying the disk is 98% full, or one process is consuming most of the CPU. The second statement is useful to the next person on the ticket. Before the next command walkthrough, lock in 2 ideas. DNS translates domain names into IP addresses. When DNS fails, a host name can fail even if the machine still has network connectivity. Now, one new command line tool, the pipe symbol, written as wow, a pipe sends the output of the command on the left into the command on the right. For example, psf head shows the first few lines of the process list instead of filling your terminal with every process. Pipes help you turn long command output into something you can inspect. You will use them constantly, but always read a pipeline from left to right. Take this output, then pass it to that command. It's Monday morning. A ticket arrives. Production website unavailable. Users receiving an error. You're the technician assigned to investigate. Don't panic, and don't start randomly changing things. Connect to the server with SSH. Once you're connected, verify where you are and confirm you're working on the correct system. Now begin collecting evidence. Check the network configuration, IP address. Check the routes, IP route. The network looks normal. Check memory, free, H. Nothing unusual. Check disk space, DF, H. There's plenty of available capacity. Now check the web service, systemctl status Nginx. There it is. Nginx has failed. But don't immediately restart it. Ask why. Check the logs. journalctl, Unix. The log reports a configuration error. Now you have something specific to investigate. You review the configuration according to your organization's change process, identify the problem, correct it, and start or restart the service using the approved procedure. Then check again. Systemctl status Nginx. The service is running. Finally, verify that the application is actually reachable. Then document the incident. What users reported, what you checked, what the log showed, what you changed, and how you verified recovery. Notice what just happened. You didn't need 50 Linux commands. You needed a small number of commands, used in a logical order. Connect. Orient yourself. Collect evidence. Check resources. Check the service. Read the logs. Fix the actual problem. Verify the result. Document what happened. That is the difference between memorizing Linux commands and beginning to think like an IT professional. Let's put several troubleshooting commands together. Start with top. This gives you a live view of running processes and their CPU and memory usage. Press Q when you're finished. Next, free, H. This provides a human-readable memory summary. Then, DF, HH. This shows file system capacity and available disk space. For a quick process snapshot, run psf head. If you're investigating a particular program, filter the process list, psf grep Nginx. Now let's move from processes to services. Run systemctl status service name. For example, systemctl status Nginx. For SSH, the service is commonly named SH on Debian and Ubuntu, and SHD on Fedora and Red Hat family systems. If the service has failed, don't immediately restart it. Ask why it failed. Check its logs. journalctl, use service name. For example, journalctl Nginx. Now you're troubleshooting instead of guessing. Check resources. Check the process. Check the service. Read the logs. Identify the cause. Then take corrective action. That sequence is much closer to how Linux troubleshooting works in a real IT environment. You've been running Linux commands one at a time. Now let's take the first step toward automation by putting commands into a bash script. Start in your home directory or another safe practice location. Open a new file with nano. Nano hello, @chesh. Now enter these 3 lines. Or, usr bin envbash. Read rp, what is your name? Name. Printf. Hello, % is name. Save the file and exit nano. Now run the script through the bash interpreter. Bash hello, sh. The script asks for your name and stores what you type in a variable called name. The printf command then uses that variable to display a personalized greeting. Notice something important. Running the script with bash hello does not require the file itself to have execute permission because you're explicitly asking bash to read and run it. If you want to run the file directly, hello.sh first make it executable. Chmod u plus x hello. The first line, iusr bin env bash, is called a shebang. It tells the system which interpreter should run the script when you execute the file directly. This small example may not look like much, but it introduces one of the most powerful ideas in Linux administration. If you perform the same sequence of commands repeatedly, you may be able to turn those steps into a script. Start small, test safely, verify the result. Then automate the repeatable work. What command shows a live view of processes, CPU use, and memory use? The answer is top. Now, how can you run the script you just saved? Use bash hello.sh to run it through the bash interpreter. Or, after adding a shebang and execute permission, run it directly with yashas hello sh. Those are two valid methods. The important part is knowing why one requires execute permission and the other does not. You now have a practical Linux foundation for entry-level IT work. You understand the difference between the Linux kernel and a Linux distribution. You can connect to a remote server securely with SSH and understand why host key verification and SSH key security matter. You can navigate the Linux file system with pwd, ls, and cd. You can create, copy, move, rename, inspect, and remove files and directories. You understand absolute and relative paths and why confirming your location before making changes matters. You can read Linux permissions, understand owners and groups, use chmod and chown, and apply the principle of least privilege. You understand the difference between a normal user, root, and elevated commands using sudo. You can identify whether a system belongs to the Debian or Red Hat family, and use apt or dnf to search for, inspect, install, and remove packages. You can inspect IP addresses and routes, test connectivity, investigate DNS, check CPU, memory, disk space, processes, and services. You can use pipes and grep to find useful information instead of manually reading hundreds of lines. And when something breaks, you now know one of the most important habits in Linux administration. Don't guess. Check the service. Read the logs. Find evidence. Make the smallest appropriate change. Verify the result. Document what happened. You do not need to memorize every command from this video. Build a small Linux lab. Break something safely. Troubleshoot it. Fix it. Then do it again. Command line confidence doesn't come from watching commands. It comes from using them. And that's how Linux knowledge becomes a real IT job skill. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.